My name is Christian Way. This is my curriculum integration and development project. In this project, we're going to be focusing on how the SAMR model can help improve the use of technology in our classroom. SAMR stands for substitution, augmentation, modification, and redefinition. Substitution is simply the technology acting as a direct tool substitution with no functional change to it. Augmentation is where the technology acts as a direct tool substitute with some kind of functional improvement. Modification makes the technology allow for significant task redesign, meaning we're going above and beyond what we could do without the technology. And redefinition allows for the creation of new tasks previously inconceivable. With this SAMR model, what that does is it allows us to move through the Bloom's taxonomy at a much more of a rapid rate. So you can see here the relationship between the different parts of the SAMR model and the different parts of Bloom's taxonomy. You can see here that it breaks down that Bloom's taxonomy into really 4 categories. Some of them overlap a little bit, but it would allow you to really dig in and hit more of the different levels of Bloom. Our goal is to be able to, in the SAMR model, is to be able to teach above the line. That means as you look at the SAMR model, you see the dotted line in the middle of the SAMR model. Substitution and augmentation are great. They really do enhance the learning of the students. But in order to really reach the students and get those students to a deeper understanding of our concepts that we're teaching in our class, we have to go above and beyond just enhancing our lessons and make it more of a transformational adjustment, which means we got to take it to a level of modification or redefinition if we hope to deepen the understanding of what we want to teach. Making reference to my own personal class that I teach, what I'm going to use for my examples here is my honors geometry class. We're in the middle of our right triangle unit, and we're looking at the right triangle trigonometry lessons. This covers multiple days, usually covers 2 days. We spend 1 day on just the concept of right triangle trigonometry, and then we move on to real life applications using angle of elevation and angle of depression. Our philosophy at Blaine High School is that we are moving towards a standard-based grading system. That means we need to evaluate our students at multiple levels in order to know what level our students are really understanding our concepts at. So in order to apply that to the SAMR model, it is critical that we implement all levels of the SAMR model throughout our lessons. So my goal here is to understand, or my goal is to get every student to the highest level possible. But in order to do that, we have to have different levels evaluated throughout the lesson. So I want to record what level my students are at as the lesson progresses. I believe I can easily do this through using the SAMR model in my lessons. Traditionally, this lesson has only taken 1 day to complete, but with raising the level in the SAMR model, we'll probably take a day to a day and a half on this lesson. To begin the lesson off, we're going to do a team building activity. Building trust within the classroom environment is key and critical to the student's success in the classroom. The more comfortable they are in the classroom, the more they're going to learn. After about a 5 to 10 minute team building activity, we will do an introduction to right triangle trig. This will be a short amount of direct instruction. We'll talk about the different side names in relation to the emphasized angle, and we'll introduce SOHCAHTOA, which stands for sine, opposite leg hypotenuse, cosine, adjacent leg hypotenuse, tangent, and opposite leg, adjacent leg, which is a nice little word for kids to help memorize the different trig functions. After the direct instruction for a little bit, we'll keep that nice and short. We're going to go into a Rally-Robin matching activity where the students will use the substitution level of the SAMR model. This activity has traditionally been done with pencil and paper. This activity represents the substitution level of the SAMR model. Because of that, it just replaces the pencil and paper. The student will be assigned a link from a Google slideshow. On the first slide, students will state their names and their group members. Students will use the Rally-Robin method to complete the problems on the Google slideshow. In this slideshow, they'll have a right triangle and 3 parts that they need to drag and drop into the correct locations to find the given triangle, or the given right triangle trig function of the. Here's an example of the Rally-Robin. This is the first round of the Rally-Robin. You'll see here is a graphical representation where you'll see the little comic book talk boxes that appear on both sides of the screen. You see partner 1 gets it started. Partner 2 will start to move things around, explaining what they're doing as they go. As they explain, partner 1 is giving feedback, just easy feedback like nice, you're doing good. At the very end, they compliment them, and they move on to they switch roles, and they move on to the next problem. After the Rally-Robin problems, what we would do is we would move on to a problem on GeoGebra. GeoGebra is either it's a web-based application, and you can also get at it through the Google Suite. But this would be a modification level of the SAMR model. This activity will strengthen their understanding of where the trig ratios come from and why they exist. In this GeoGebra activity, students will be paired up and they'll be asked to draw 3 similar right triangles in GeoGebra. Using this program, they will be asked to find the missing angle measures and missing side lengths of all 3 of their similar triangles. Then using the trig ratios, they'll represent how the sine, cosine, and tangent of each of these similar triangles is the exact same, no matter what the size of those triangles are. Students will then be asked to create a 4th right triangle that is similar to the other 3. Using GeoGebra to find one of the angles and one of the side lengths, they'll use trig then to find the missing side length, any of the other missing side lengths. This will become a rally coach structure where partner 1 solves the problem on the computer screen by using paper, pencil, and a calculator. Then partner 2 will encourage partner 1 along the way, and then once the problem is done, they'll use GeoGebra to find the missing side length that partner 1 tried to find and evaluate their accuracy. Students will switch roles back and forth and repeat until time expires. Students can request to demonstrate their knowledge as evidence towards their learning. This could be used from a teacher's perspective to help towards their earning of a level 2 proficiency level or a B level proficiency level on their unit assessment. At this point, there would be some time here where there would be the need for some direct instruction. Again, I want to limit the amount of direct instruction given during this lesson, but we would need to talk about how to solve the different situations algebraically that come up when we're trying to solve equations involving trig ratios. Whether the variable ends up in the numerator, the denominator, or within the trig function itself, there's a little twist here and there of how to solve these equations using the algebra. After this direct instruction, it is a good time and place to check for the student's understanding. We'll do this by using a quiz on Moodle. Students are required to show their work on a piece of paper or on their device. For example, they could use Notability on their iPads. This is a formative assessment that will not affect their grade, but it will appear in their grade book. They have multiple attempts on this quiz. We will always take the highest grade that they demonstrate on this quiz. They will receive this grade. It will let the students. It will be instant feedback. This will let the students know where their proficiency level is at that point in time, and whether or not they need more practice or are they good to go and ready to move on to the next level. This check for understanding quiz would fall under the augmentation level of the SAMR model, because this quiz is it simply replaces a pencil and paper quiz. The only additional piece that it gives that makes it augmentation over substitution is the fact that it gives you instant feedback and it tells you which problems are right and wrong. It allows students to retake the quiz as many times as they need in order to get to be at a proficient level. Traditionally, after the check for understanding, we would allow students to move on to their homework assignment and be done. But at this point, this is a great opportunity after we've evaluated the SAMR model to go above and beyond traditional learning and dig deeper into Bloom's taxonomy by allowing the students to create something above or go beyond, just go further with their understanding of the concepts that we have taught. So in this, what we came up with is that students can start to brainstorm about a video representation of how to use right triangle trig to accurately estimate the height or the length of a real-life object. This could be done anywhere. You could do this in the classroom. You could send kids out in the hallway. You could send them down to the gym to measure the height of a rock wall, or in the library. Our library has a balcony. You could measure the height of the balcony. You could send them outside. There, we got a bunch. I mean, we're right next to a wooded area that can measure the height of trees or whatnot. There's a lot of opportunity for kids to measure different things that are currently in the real world without actually being able to take a tape measure and measure them. I would have some tools available for them as they start to think about and want to start measuring and figuring out how to set up their video. They'd come up with a plan. This is obviously something that would not have to take place within the class period, but an extension on the lesson that they could dig deeper into and elaborate on their own time. This video presentation could be used as evidence towards their level 3 or A-level assessment questions, where maybe they make some minor mistakes or make some mistakes that are not huge mistakes on the A-level questions and still earn that level of proficiency on the assessment at the end by using this video as additional evidence. This project would be an example of redefinition in the classroom. The redefinition is the highest level of the SAMR model. Students would use their own personal devices or a classroom iPad to create this video of how to use the right triangle trig to indirectly measure the length or the height of some real-life object. The project can be done either in the classroom or at home. Obviously, the classroom time is going to be limited, so possibly at home or during a study hall or some other time, possibly. Students need to record themselves making the initial measurements, talk through the calculations, demonstrate the calculations, and validate the responses or the results. It's possible, if it's possible, to directly measure the object that they calculated. This would be this would be good validation towards their answer that they received or that they got using the trig ratios. If it's not possible to directly measure the object. Let's say they used a tree out in their yard or their house or something along those lines. Then they would need to repeat the same process multiple times, given different angle measures and different lengths, and show that they get the approximately the same answer. Obviously, it's not going to be exactly the same because there's going to be some rounding errors that happen in the process, but they should get the same result multiple times in their video presentation. In conclusion, working the different levels of SAMR into a lesson has created the opportunity to individualize the learning of students. Students are able to demonstrate, and teachers are able to evaluate the different levels of knowledge throughout the lesson. This gives students and teachers a variety of ways of evaluating the student's level of knowledge throughout the lesson and throughout the unit, creating opportunity for students to go above and beyond and truly branch out and reach levels that have previously been unattainable.